right, Algebra 2, this is Mr. Lamb coming to you with the last video for the Algebra 2 final exam review. This is Unit 10 polynomials. This is the stuff that we just recently went over, dealing with some of the factoring and the fundamental theorem of algebra and a lot of that good stuff. So let's go ahead and dive right in, and let's see if we can't finish this thing up. 37, 38 both want you to factor. These are both perfect cubes. So when I look at this, x cubed and 64. So the cube root of x cubed is x. The cube root of 64 is 4. And then if you remember, square multiply square. So square your x, multiply the two together, square your 4. And now I only have to worry about the signs. The signs follow what we call SOAP. So I'm looking at the sign in the middle right now, and it is the same, so negative. Opposite, so positive. And then AP is always positive. That's what SOAP stands for, same, opposite, always positive. 38, same process. The cube root of 8x cubed is 2x. The cube root of 125 is 5. And then I'll square multiply square. So square your 2x, give you 4x squared. Multiply the two together, 2x times 5 is 10x. Square your 5, that's 25. And these signs get SOAP, same. So I'm starting with a positive, so same, opposite, always positive. Real quick and easy way to factor two perfect cubes. All right, number 39 says, what are the zeros to this polynomial? And the first thing you can do, a couple of different ways you can do this. Maybe you look at this and see that this does factor. All right, as I look at this, I see that this one factors. So I have x to the 4 and x to the 2 in the middle. So this will factor as x squareds out in front. And two things that multiply to give me 36 and subtract to give me 5 are 9 and negative 4. 9 times negative 4 is 36. 9 minus 4 is 5. And then if I want to solve these two things, x squared plus 9 equals 0. So x squared equals negative 9. So x equals positive or negative the square root of negative 9, which I know is 3i, the square root of a negative number. The other one is x squared minus 4 equals 0. So x squared equals 4. Square root both sides, x equals positive or negative 2. So because it is x to the 4th, I do know that I need 4 answers. I get 3i and negative 3i, that's 2 of the answers, and then 2 and negative 2 are the other 2 answers. Number 40. What are the roots of this equation? First thing I'll try to do, I'll try to factor it. So I'll factor by grouping since there are 4 terms. The first two things have an x squared in common. If I were to factor out an x squared, I would have 2x and minus 1 left. And negative 18x and positive 9 have a negative 9 in common. And that would leave me with 2x minus 1. So great, this thing factors. This factors as 2x minus 1 and x squared minus 9. So if I want to find the roots are when this thing is equal to 0. So I take 2x minus 1, set it equal to 0, add 1, divide by 2, so x is 1/2. That's one root. I need 3. X squared minus 9 equals 0. X squared equals 9, and x equals positive or negative. The square root of 9 is 3. So my 3 roots are 1/2. And then 3 and negative 3. Number 41 wants to know for what values of x does the graph 4x squared minus 12x plus 9 intersect the x-axis? I'm going to just go to the calculator. This is easier to do in the calculator than anything else. Move this out of the way. Y equals 4x squared minus 12x plus 9. Take a look at the graph. And I see that it hits the x-axis. So I'm going to zoom that in. I know it's between 1 and 2. I'm going to go to my window. I want to take a look at from 1 to 2. And I'll scale this by 0.1. So I'm really going to zoom this thing in. And I'm going to actually take my y's from -1 to 1. So let's really zoom this thing in. So that is really, really tightly zoomed in. And if I want to calculate the x-intercepts, second calculate, and I want to know the 0, so 2, and then it says left bound. I go over here to the left, and then I'll go to the right. If you notice the y's, you'll notice when I get real close to the bottom, right there it is actually, there's your 1.5, you see it. And then guess, and you can see that it's 1.4999999, which is a 1.5. So for what value of x? Well, when x equals 1.5, which is 3/2, as your key says. Number 42, determine the solutions to the polynomial. So again, I'm just going to put this thing right into the calculator. Y equals 2x to the third plus 5x squared minus 12x. And take a look at the graph. Double check that. 2x to the third plus 5x squared. Hang on. I missed a minus sign in there. Minus 12x. Let's see now. This should look, there it is. That looks better. And if I want to find the zeros, I'm just looking for those 3 points right there. So I know there are 3 of them. It is 2x cubed. So I'm going to go ahead and calculate these. So second, calculate. Let me show you another way. I can take a look at these values actually. I can just go to the table. And I will kind of look back and see if I see some zeros. So I see 2 of them. I see one at -4 and one at 0. So x equals -4 and x equals 0. Those are 2 of my answers. I saw that just looking at the table. Now the third one I can't find. And when I look at the graph, you'll see that the third one falls between 1 and 2. So I'm just going to calculate that one. So b to the left, it is. B to the right, it is, and then guess. And it's 1.5. There's using your calculator to determine some solutions. Number 43, that asks, wants us to, what is the cubic polynomial? Okay, well this is set these so they say something equals 0. So right now I have x equals 2. If I subtract 2 on both sides, I get x minus 2 equals 0. That is going to be one of my factors. I'll set it over here. X minus 4, add 4 to both sides, so x plus 4 equals 0. That'll be one of my factors. And x equals 0, that's already set equal to 0, so that's one of my factors. If you want the cubic in standard form, take your x minus 2, your x plus 4, and your x, and just multiply everything together. So I'll FOIL my first 2 together. That'll give me x squared plus 4x minus 2x minus 8. Multiply that by x. Combine some like terms. So that'll be x squared plus 2x minus 8. When I multiply through and I multiply my next x in, x times x squared is going to be x cubed. X times what? When I combine these, I'll have 2x. So 2x times x is 2x squared. And negative 8 times x is negative 8x. So my cubic polynomial should be x cubed plus 2x squared minus 8x. Number 44, if 3 plus radical 6 is a root of a polynomial, what also must be a root of the polynomial? This is true especially with parabolas because of the concept of the opposite of b plus or minus the square root. This is when we start thinking about our conjugate pairs. So if 3 plus radical 6 is 1, then 3 minus radical 6 also has to be 1. This really works well with complex, but we did also show with rational, irrational roots. If 3 plus radical 6 is 1, then 3 minus radical 6 must be 1 as well. All right, moving on to 45. So here we go. What are the other two roots? Again, this is the same conjugates theorem. So 2 plus radical 10, and if I have 4 plus 7i, then 4 minus 7i. Just changing those signs, we call those conjugates. Making sure that we are doing those conjugate pairs. Number 46 says a polynomial with real coefficients has I and 7i as two of its roots, which means negative I is a root, and it means that negative 7i is a root, because we know that those things come in pairs. They always do. So it says, what is the least possible degree of the polynomial? Well, how many roots is the fewest it could have? Well, it's going to have 1, 2, 3, 4. So it's going to have, at minimum, a fourth degree. Number 47, how many times does the graph 8x cubed minus 27 cross the x-axis? Easiest thing there is graph it. 8x cubed minus 27. Take a look at the graph and count how many times it crosses. And you see it right there. It crosses in one spot. So number 47, it only crosses in one spot. Number 48, find a polynomial function in standard form with the given information. It must be a cubic with the following zeros. So if the 0 is 7, that means x minus 7 is one of the roots. And then the 3 plus or minus 4i, I really like this. I like to think about x equals 3 plus or minus 4i. So if I subtract 3, that means x minus 3 equals 4i. Remember what 4i is. 4i is the square root. Square root of a negative number, actually. And the square root of what number would be 4? Well, the square root of 16 is 4. So if I think about this setup, that x minus 3 is equal to the square root of negative 16, I'll square both sides. Square the right side, I get 16. Be careful squaring the left side. X minus 3 squared is equal to x minus 3 times x minus 3, which means you have to FOIL it. So this is actually x squared minus 6x plus 9 when you FOIL and combine like terms. Get this so it is set equal to 0. Subtract 16 on both sides. So x squared minus 6x. If I do 9 minus 16, I would get negative 7. The 0. So I'm going to take my x squared minus 6x minus 7 and my x minus 7, and I'm going to FOIL those two things together. So x times x squared is x cubed minus 6x squared minus 7x. And when I FOIL the negative 7 times x squared is negative 7x squared. Negative 7 times negative 6 is 42x. And negative 7 times negative 7 is 49. And combine these like terms. X cubed minus 13x squared plus 42 minus 7 is what? 35x plus 49. Number 49, given that the polynomial 2x squared, x plus 2, x minus 3, complete the following. The degree. Now think about roots. Here is x squared, that's 2 roots. Here is x to the first, that's a 3rd root. Here is x to the first, that's a 4th root. So it is degree 4. The maximum number of turning points is always the degree minus 1. So 3. Standard form. Now FOIL this stuff together. So x plus 2, so if I FOIL this, that's x squared. Minus 3x plus 2x is minus 1x, and 2 times negative 3 is negative 6. If I distribute the 2x squared, that would give me 2x to the 4th minus 2x to the 3rd minus 12x to the 2nd. The classification, first of all, it is a power 4, so we call that a quartic. Remember, we have a, if it is degree 1, we call it linear. Degree 2, we call it quadratic. Degree 3, we call it cubic. Degree 4, we call it quartic. And degree 5, we call it quintic. So this is a quartic. And now I count how many terms there are. 1, 2, I see 3. So that is a quartic trinomial. You have a binomial if it's 2, trinomial if it's 3. And then after that, we just call it polynomial 4, whatever the case may be. The end behavior, I can do a couple of things. I can just type this into my calculator if I want and graph it. But since I see the standard form, I'm actually just looking right here. I'm looking at this term. Since it is degree 4, they point in the same direction because 4 is even. And since the lead term out in front, 2, is positive, that means they're both up. They both point up, so they're up and up. F says state the zeros, then determine their multiplicity. So I'm going to look back at right at the beginning, and if I said 2x squared equals 0, divide by 2, so x squared equals 0. So this is actually 2 different roots. So this is x equals 0 with multiplicity 2. Which means, if you remember, it just touches the axis there. It's going to touch and turn. The next root is x plus 2. So x plus 2 equals 0. So x equals negative 2. That just has a multiplicity 1. So that's going to cross over the axis there. And x minus 3 equals 0. Add 3 has a multiplicity of 1, so that is also a cross. So anytime it has multiplicity 1, it just intersects, it crosses, it goes right across there and goes forward. Part G says algebraically determine the y-intercept. So the y-intercept is when this equation equals this is when we plug 0 in for x. So I will go 2x squared, so 2 times 0 squared. And we'll multiply that by 0 plus 2. And we'll multiply that by 0 minus 3. So when you are algebraically trying to find the y-intercept, this is, the y-intercept by definition is plug 0 in for x and solve for the y. Well, 2 times 0 squared is 0. 0 plus 2 is 2. 0 minus 3 is negative 3. And if I multiply 0, 2, and negative 3 together, I get 0. So the y-intercept is at the point 0, 0. All right. The next part says sketch the polynomial on the axis below and fill in the table at the right with the appropriate values. And it even tells you kind of what to put in there. So let me go back so I can see my equation. And y equals 2x squared x plus 2 x minus 3. And now let's take a look at the window it tells me to use. So I'm going to hit my window here. It says x min negative 5, x max 5, scale by 1, negative 32 to 10, and scale by 2. Let's take a look at that graph. So I'm just going to steal this picture over here. Instead of taking the time to draw it, you can obviously go ahead and sketch that in yourself. I am going to take a look at the table. So if I go second graph, and I want to fill in my table, so I'm going to pull this screenshot off so we have it right next to it. So when x is negative 3, you'll see that y is 108. When it's negative 2, you'll see it's 0. We knew that one though. When it's negative 1, it's negative 8. 0, 0, we knew that one. 1 is negative 12. 2 is negative 32. 3 is 0. And 4 is 192. All right, number 50, divide using polynomial long division. Unfortunately, calculator is not going to help you much here. This is just understanding the process of long division. So I figure 2x, what would I have to multiply 2x by so it will equal 10x to the 4? Well, 2 times 5 will give me the 10. And x times x cubed will give me x to the 4th. So now I'll distribute that. 5x cubed times 2x is 10x to the 4. 5x cubed times negative 3 is negative 15x cubed. Draw the line and change the signs. So that becomes a negative, that becomes a positive. When I add straight down, my first one is 0, and then negative 13 plus 15 is 2x cubed. My 7x squared, 8x, and 4 all come down. Repeat the process. 2x times what will give me 2x cubed? Well, 2 times 1 will give me 2. And x times x squared. So we'll multiply this by x squared. X squared times 2x is 2x cubed. X squared times negative 3 is negative 3x squared. Draw the line. Change the signs. Negative, positive. Add straight down. Negative 7 plus 3 is negative 4x squared. 8x and 4 drop down. Repeat the process. 2 times what gives me negative 4? So I need a negative 2, and x times x will give me the x squared. Distribute. Negative 2x times 2x is negative 4x squared. Negative 2x times negative 3 is 6x. Draw the line. Change the signs. Change this to positive. Change this to negative. 8 minus 6 is 2x plus 4. And what do I have to multiply 2x by to get 2x? Well, I multiply by 1. So that'll give me 2x minus 3. Draw the line. Change the signs. My remainder is a 7. So my remainder, I will add on, is 7/7. over 2x minus 3. That is my remainder, and that is polynomial long division. Good way to check it is with synthetic division, which is what question 51 wants us to be able to do. Let's take a look at synthetic division. The only thing you have to be careful of with any of the long or synthetic division is make sure that if you are missing a term that you just fill in a 0 in its place. So synthetic division, as I look at x plus 2, what would make that a 0? The root is a negative 2. So that is my root. I'm going to divide by negative 2. So my coefficient is going to cross. X to the 4th is my highest, so the coefficient is a 3 for x to the 4th. It is a 6 for x to the 3. It is nothing for x to the 2. It is negative 2 for x to the 1. And it is 4 for the constant. Synthetic division, drop your first one straight down. So the 3 drops down. And now I start multiplying. Negative 2 times 3 is negative 6. Add straight down is 0. Multiply. Negative 2 times 0 is 0. Add straight down. Multiply. Negative 2 times 0 is 0. Add straight down. Multiply. Negative 2 times negative 2 is 4. Add straight down. The last one is always my remainder. I'll just put an R there so you see it. Now, since I started at x to the 4th, this will be my x to the 3rd term. This will be my x squared. This will be my x. This will be my constant. So when I write my answer, 3x to the 3rd plus no x squared plus no x minus 2. And then the remainder is 8. So 8 goes over top of x plus 2. That is synthetic division. And now our final question. Number 52, find all the roots of the polynomial. Use the rational root theorem and synthetic division. So the rational root theorem wants us to do things that could multiply to give me a p. So for p, these are all positives and negatives, the whole list. 1, 2, 3. Does 4 divide into 60? Sure does. 5, 6, 7 does not. 8. No, 9, no, 10. 11, 12 does. 13, 15 does. 20 does. 30 does, and 60 does. For Q, 1 and 2. So as I think about all of these possible rational roots, I have 1 over 1, 2 over 1, 3 over 1, 4 over 1, 5, 6, 10, 12, all of those over 1, and then again all of them over 2. But instead of just checking all of these, I'm going to use the calculator to my advantage. So y equals 2x to the 4th minus 13x to the 3rd plus 23x squared minus 52x plus 60. Let's check it. 2x to the 4 minus 13x to the 3 plus 23x squared minus 52x plus 60. And what I'm going to do is I'm going to go to my table and I'm going to ask it some values. So when I go back to this graph now, I can just put in the values I want. I'm going to try 1. It didn't work. I'm looking for zeros. 2, 3, 4, 5. 5 works. I'll write that one down. 6, 10, 12, 15, 20, 30, 60. All right, so the only one out of the positives that worked over 1 was 5. So now let's try the negatives. Negative 60. No. Negative 30. No. Negative 20. No. Negative 15. Negative 12. Negative 10. Negative 6. Negative 5. Negative 4. Negative 3. Negative 2. Well, negative 1. So none of the negatives over 1 work. So I only have 1 right now. Let's try these over 2. Let's go 1 over 2. Didn't work. 2 over 2 is 1. I've already checked that. 3 over 2. That one worked. So I know it's 2x to the 4th. I need 4 of them. I have 2. Try a couple more. 4 over 2 is 2, and I've already checked that. 5 over 2 doesn't work. 6 over 2 is 3, and I've checked that. 10 over 2 is 5, and I've checked that. 12 over 2 is 6, and I've checked that. 15 over 2. I haven't checked that one yet. That one didn't work. 20 over 2 is 10, and I've checked it. 30 over 2 is 15, I've checked it. 60 over 2 is 30, and I've already checked it. So those are now, so I guess I have to try the negatives of these as well. So let's go negative 1/2, negative 1.5, negative 2.5, negative 7.5. So only 2 of them end up being rational. So a lot of work for just 2 rational roots. That means my other 2 roots are probably irrational or imaginary. So I'm going to do my synthetic division. I'm going to take my first rational root. I don't care. I'll use 5. So 2, negative 13, 23, negative 52, and 60. And you can bet when you divide this down, you better get a 0 remainder. So the first one drops straight down, it's a 2. 5 times 2 is 10. Negative 13 plus 10 is negative 3. 5 times negative 3 is negative 15. 23 minus 15 is 8. 5 times 8 is 40. Negative 52 plus 40 is negative 12. And 5 times negative 12 is negative 60, which has a remainder of 0. That better happen. We knew that was going to be a root. So now I'm going to do 3 over 2. It's going to be the next one. Better get a remainder of 0 again. So 2 drops down. 3 halves times 2. So that's 3. Negative 3 plus 3 is 0. 3 halves times 0 is 0. It's 8. 3 halves times 8 is 12. Remainder of 0. So it was x to the 4th. When I divide the first time, it makes it x to the 3rd. I divide a second time, it makes it x squared. So this is 2x squared plus 0x plus 8 has to equal 0. In order to solve this, let's just use some Algebra 1 skills. Subtract 8. So 2x squared equals negative 8. Divide by 2. X squared equals negative 4. Square root. X equals positive or negative the square root of negative 4, which is positive or negative 2i. So my 4 roots are 5, 3 over 2, 2i, negative 2i. Those are your 4 answers. That's it. That's all I have for your Algebra 2 final exam review. I wish you the best of luck as you study and prepare. Make sure your calculator has batteries. It will help you immensely. Be sure that when in doubt, try plugging answers in and just use your calculator and use the guess and check method as you go forward. on the review. As I did the actual test itself, I would say about 75 to 85% of the test you can do just using the calculator if you are proficient with it. So best of luck studying. Have a great weekend, and I will see you Monday.